Welcome to today's episode, where we dive into three exciting frontiers in AI audio: privacy-preserving speech translation, unified speech tokenization, and free-form audio generation. We'll look at how a split-inference system can keep raw voice on device while still translating across dozens of languages, how HoliTok from Shanghai Jiao University and Xiaohongshu is building a single representation for both speech understanding and generation, and how PlanAudio, powered by Qwen 2.5, is turning plain text into rich compositional speech and sound. Let's explore the first paper, Bandwidth-Efficient and Privacy-Preserving Edge Cloud, Many-to-Many Speech Translation. Bandwidth-Efficient and Privacy-Preserving Edge Cloud Many-to-Many Speech Translation introduces ESRT, a split-inference speech translation framework that keeps a frozen whisper encoder and Q-former-based speech adapter on device, then sends only compressed intermediate tensors to a cloud LLM instead of raw audio. This design cuts transmitted data from a 30-second WAVs 0.92 megabytes to about 0.06 megabytes, a 15.6 times reduction, and the paper reports up to 10 times bandwidth savings in practical many-to-many usage. Privacy is strengthened through four mechanisms: lossy information bottlenecking, fixed shape tensor transmission that obfuscates the backend model, 30-second padding that hides utterance duration, and implicit language encoding that avoids explicit language tags. To address English-centric bias and catastrophic forgetting, the authors add a multitask-weighted curriculum over ASR, speech-guided MT, and speech translation, with language token vocabulary expansion and optional LoRa fine-tuning. On floors, ESRT 12B reaches state-of-the-art comment across 45 languages and 44 directions, averaging 83.8 for X44 and 83.4 for 44X, outperforming MCAT, large, 27B, while using less than half the parameters. ESRT 4B also exceeds the 27B baseline on several settings. The paper's broader claim is that strong many-to-many speech translation can be achieved without uploading raw voice, making edge cloud deployment both more bandwidth efficient and substantially safer for privacy. Let's explore the second paper, HoliTok, a continuous holistic tokenization with robust dual capabilities of speech generation and understanding. HoliTok, from Shanghai Jiao University's X-Lance Lab with High Lab at Xiaohongshu Inc., proposes a continuous speech tokenizer for unified generation understanding systems, targeting a representation that is simultaneously decodable, compact, and learnable by a language model. It encodes 48 kHz audio into a 25 Hz sequence of 128 dimensional latents using a low latency VAE with causal striated convolutions, a temporal variational bottleneck, and a big vegan-style decoder. Its key novelty is a three-stage progressive training recipe. First, a deterministic autoencoder for waveform fidelity, then weak KL regularization to convert that manifold into a smooth, stochastic latent space, and finally, downstream aware enrichment with WAVLM, frame-level distillation, X-vector utterance-level distillation, and task-conditioned supervision for ASR, emotion recognition, audio captioning, and sound event detection. In unified AR plus DIT experiments using a Qwen 2 5-0 5B backbone, HoliTok is the only representation that works robustly without extra optimization tricks. On LibreSpeechTest.other, it reaches PESQ 4, 10/4, 1, STOI 0.974, WER 4.22%, SPKSIM 0.968, and EMOSIM 0.995 at a 7.5 times compression ratio and 25 tokens per second. In zero-shot TTS, it outperforms semantic VAE and Mingtalk audio on Seed TTS Evol and Emergent TTS, and the HoliTok Unite variant improves unified ASR TTS balance, cutting average TTS WER from 20.9% to 8.59%, and ASR WER from 12.63% to 8.02% over HoliTok base. Let's explore the third paper, Unified Synthesis of Compositional Speech and Sound from Free-Form Text Prompts. Renmin University of China's PlanAudio reframes audio generation as free-form text prompt to unified audio synthesis, where a single unconstrained prompt must produce speech, sound, or tightly interleaved composites without external text rewriting. The key novelty is a unified autoregressive LLM backbone initialized from Qwen 2, 5, to 1. 5b, that bypasses a separate text encoder and inserts a semantic latent chain of thought stage. The model first predicts a compact continuous planning sequence Z, supervised by segment-level embeddings from Audio Flamingo 3, then generates hierarchical AudioCraft codec tokens conditioned on both the prompt and Z. To evaluate this setting, the authors build PlanAudio Bench from AudioSet with decoupled annotations via Whisper and Gemini 2. 5 Pro, using 4,500 held-out composite examples, and a 1, 2, 7, M example training pool spanning 371K composite, 451K sound, and 354K speech clips. Across composite benchmarks, PlanAudio improves substantially over pipeline and unified baselines such as voice LDM and audio LDM 2 combinations, reducing FAD from 22.9, 25.2 down to 8.52, and lowering WER to 0.41, while achieving the best human ratings for quality, temporal correctness, semantic alignment, and authenticity. Ablations show that semantic latent CoT outperforms explicit natural language CoT and acoustic token CoT, and that a constant multi-scenario curriculum is crucial to avoid catastrophic forgetting. That's a wrap on today's AI paper highlights. Thanks for watching.